Hello everyone, I'm Mengxiao, a PhD student from the University of Auckland. This is a joint work with my supervisors Fernando and Jiamou. Firstly, let's consider this situation. A person, which we call a data broker, would like to learn some aggregate information of a population. To get the information, he queries on a set of privately held data records, such as income records, consumption records, and preferences data, and produce some aggregate statistics. At the same time, the data broker needs to provide some monetary compensations to the data owner. So, private query mechanism conduct queries on privately held data and compensates data owners accordingly. Designing such a query mechanism is challenging. Firstly, there is an increasing concern about privacy protection, especially after the Equifax and Facebook data breaches. So the query mechanism needs to guarantee privacy protection for the data owners. Also, to preserve privacy, some noise has to be added to either data sets or the query results. But what a data broker wants is accurate query answer in order to make better decisions. So, how to get the accurate result while preserving privacy is another challenge. At last, each data owner has a valuation for its private data, um, and is known by the data owners themselves, but hidden from anyone else. It is known as information asymmetry. So the query mechanism to provide some incentive in order to reveal the true valuation of data owners. Actually, a similar problem has been explored in a previous study by Ghosh and Rose. They consider problem of privacy trade. In their study, they assumed that the data broker, by providing sufficient incentives, could purchase an arbitrary amount of privacy from any data owner. So it's up to the data broker to determine the privacy level. But in practice, it is not the case. Data owners often have intrinsic privacy requirements, and they choose to interact with organizations only when they believe that organizations can meet their privacy requirements. So, in our study, we consider a different setting where the data owners are single-minded. That is, they would not release their data unless their requested level of privacy protection is met. So our contributions lies in firstly, we propose a new problem with single-minded data owners. Also, to solve this problem, we proposed a new private query mechanism, single-minded query or SMQ. Before I go to the details of the SMQ, I would like to introduce some preliminaries. Firstly, in this study, we apply personalized differential privacy to quantify privacy. Given a pair of data sets that differ on the ith entry, the corresponding query answer should be very close in a probabilistic sense. The closeness is measured by parameter epsilon I. Then we apply the PE mechanism to achieve personalized differential privacy, since the PE mechanism can be applied to arbitrary real-valued queries. The next is about procurement mechanism. Now consider a trade between a single buyer and multiple sellers, and the buyer has a budget for the procurement, and each seller has a valuation of the item. The valuation is hidden information, but the probability distribution about the valuation is public known. The buyer's problem is to design a direct mechanism that consists of an allocation function and a payment function. And for each buyer, he would like to maximize the expected utility. The procurement mechanism should satisfy some properties. Firstly, incentive compatibility ensures that each seller truthfully reports his valuation, while individual rationality ensures that each seller is willing to participate in the mechanism. While at last, budget feasibility ensures that the total expected payment is bounded by the budget. So in this study, one consider a data trade between multiple data owners and a data broker. Each data owner is associated with a data entry, and each of them has a data valuation and a privacy requirement. And the data broker has a query and a budget for the data collection. Given a budget and a query, the data query mechanism firstly apply a procurement mechanism that purchase data from a subset of data owners and construct a sample data set. Then the PE mechanism is applied to the sample data set and returns the noisy query answer to the data broker. So the question is how to design the procurement mechanism to get an accurate query answer. Here we use alpha delta PAC to measure the accuracy of the mechanism, which measures the difference between the noisy query from the sample data set and the true query answer from the ground truth data set. Then how to select data owners to get the most accurate query answer? We have this lemma. It says that the sum of the purchased privacy plays a significant role of determining the accuracy of the mechanism. Further, in our study, we concerned with expected utility. So in our query mechanism, we aim to maximize purchased privacy expectation. That is, we aim to solve the following optimization problem. The objective is to maximize the expected purchased privacy, while the incentive compatibility, individual rationality, and budget feasibility constraints are satisfied. By solving this optimization problem, we can get a procurement mechanism, and we prove that this mechanism guarantees to find the optimal solution to the optimization problem. Also, we proposed an algorithm to implement the procurement mechanism. Firstly, it obtains a valuation threshold for each data seller. When the reported valuation is less than the threshold, the data seller is selected and will be paid accordingly. After the data selection, the PE mechanism will be applied to the sample data set. So the single-minded query mechanism satisfies incentive compatibility, individual rationality, budget feasibility, and personalized differential privacy. Also, it can achieve high accuracy. At last, we conduct experiments on 3 real-world data sets with 3 query types. Also, we compared the performance of SMQ with 2 existing query mechanisms, FQ and FIP. The results show that our proposed mechanism outperforms the existing mechanisms. That's it. Thank you very much for your listening.